All right, welcome everybody to today's webinar hosted by the International Solar Energy Society ISES. This is a very special webinar for ISES as we are introducing the latest set of ISES infographics to you. We are very pleased to have all of you here, and we are especially happy to welcome our 3 expert speakers introducing us to solar thermal applications from all around the world. My name is Arabella. I am the Communications and Outreach Officer here at the ISES HQ in Freiburg, Germany, and I will give you a short introduction into ISES and the work we do, as we have many new participants joining us on the webinar today. I will then also introduce you to our ISES infographics to give you some more background information. The International Solar Energy Society ISES is a non-profit UN-accredited membership NGO. Our vision is 100% renewable energy for all, used efficiently and wisely. ISES represents a diverse membership of academics, researchers, engineering practitioners, consultants, students, businesses, and advocates. ISES works together with like-minded organizations from countries all around the world to advance the renewable transformation. There are many benefits to joining ISES, and you can find out more on our homepage. Some of the benefits are the exclusive access to presentations and webinar recordings, such as today's in the ISES webinar archive. ISES members can also get discounts and even free registrations to ISES events and partner events. Every month, ISES publishes a newsletter for our members where you can follow our progress and share your news. Members can also subscribe to our academic journal Solar Energy, our flagship publication, at a reduced price. And in the ISES online bookshop, ISES members qualify for reduced prices on the different publications. So we welcome those who are not yet members to join today to support our work. For those who are already a member, we thank you for your support. As a special benefit to all attendees of today's webinar, we are very happy to offer a special discount when signing up as an ISES member. All attendees of this webinar will receive a 20% discount code as a follow-up to this webinar over the next few days. This special offer will only be valid for 2 weeks after this webinar, so sign up quickly and join ISES and the global solar community. Additionally, ISES is happy to highlight that webinars like these are a great way to show your support by becoming a webinar sponsor. This can be especially interesting for companies and institutions working in solar, as our webinars have 500 and more registrants, and the webinars offer speaking slots as well as the opportunity to introduce your latest project and product. For any information, please do not hesitate to get in touch at public.relations@ises.org. Now for some brief information on the webinar and especially the Q&A section. As I mentioned, my name is Arabella. I am coming to you from the ISES HQ in Freiburg, Germany. And today we are going to discuss 3 presentations on different applications for solar thermal heat in industry processes. And to get started, I will be introducing the ISES infographics to you for some more background. For the Q&A section later in the webinar, we invite you to send in your questions, and we are looking forward to your participation. Please remember, when sending in the questions, please write who the question is for and keep your questions short and precise. Now for the ISES infographics. In 2018, ISES started the infographics as a new method for outreach, education, and support for the global solar community. The aim was to create a tool that can help people in communicating renewable energy in an easy way, and therefore helping renewables and solar to power the renewable energy transformation. The first installment in 2018 was called Dispelling the Myth, Renewables in the Grid. For this, the ISES Board of Directors got together and collected 8 of the most commonly claimed shortcomings of renewable energy and countered these myths utilizing the research which organizations such as ISES have conducted over the last 60 years. The 8 graphics discussed issues such as grid integration, storage, the reliability of renewable energies, their availability and transmission. Together with a set of easy-to-read graphics, these 8 myths were then debunked. You can find these graphics on the ISES homepage, download them and share them online. They are a free resource, and we invite all of you to use and share them widely. In 2019, ISES then got back together again to produce and to launch the second set of infographics. This time the infographics are focusing on the production of everyday consumer goods such as beverages, electronics and medicine, and the infographics show how solar in the form of solar thermal heat is used in industry processes to create these products. It is the intention of this set of infographics to really highlight the already existing value of solar for industry processes And by choosing real-life products, readers can gain a greater insight into the possibilities of solar and renewable energy. This way, solar energy and solar heat do not remain abstract concepts, but instead become part of people's everyday life. This latest set of ISES infographics was launched at the recent ISES Solar World Congress in Chile. And for 2020, ISES has already planned the next set of infographics, this time focusing on solar applications for homes. So we invite you to stay tuned for the next infographics coming up in 2020. And again, you can find all these graphics on the ISES homepage, download them and share them online. They are free to use for all. Now, we are coming to the first example of one of our infographics, which we've called Brewed by the Sun. And I'm now happy to introduce you to the first speaker of today, and he's also going to moderate later on, which is Stephen Myers. Stephen Myers served on the ISES Executive Committee from 2016 to 19, heading the ISES Infographics Working Group and putting together this great publication. Steve, the floor is yours. Please go on.
Thank you very much, Arabella, and good morning and good afternoon, everybody. Thank you for joining the webinar today. It's my honor to speak a bit about solar thermal heat for the beer brewing process. So first, I'd just like to go through a few examples and kind of show like how the solar thermal best fit into the beer brewing process, what sort of collectors can be used, and how solar can be a part of a holistic green brewing type concept. So the first concept I'd like to show here is an example of the Hoot Brewery here, which is close to Kassel University, which is where I did my dissertation. And this is located here in central Germany. So the benefit of both Germany and Austria of recent years is they had a very supportive financial system that supported up to 50% of a project cost, which really helped to kickstart some of the solar thermal applications for industrial heating. And Germany, as many people know, is quite famous for beer brewing. So there have been a number of solar thermal projects within this sector. So within the beer brewing process, there are a number of different processes which require heating. There's mashing, lautering, boiling, which is obviously a heating process, and then finally cooling, which is obviously a cooling process. But the most important thing when designing a solar thermal system, or the best way to integrate solar thermal into an industrial process, is to keep the plate temperature or to keep the application temperature as low as possible. And what that allows you to do is really get the highest yield out of your solar collector, which means the lowest cost per kilowatt hour of thermal energy. And in this case, in this application, the best place to integrate the solar thermal tank or the solar thermal system was into cold water preheating. So the water that would eventually be used to brew the beer and that will physically become the beer that you drink was to preheat the groundwater from 5-10 degrees Celsius up to 40, 50, 60 degrees Celsius during most operations, but even up to 80 or 90 during the summertime. So for this application here at Hoot, there's about 155 square meters of collectors here. This is integrated to do the freshwater preheating, and to put this into perspective, this was about the same size that you could fit into 30 single-family homes to meet their domestic hot water use. So one other good use that one can also do within the beer brewing process is also the heating of hot water that will be used for cleaning in place. And what that is after all the beer brewing is done for the day, there's still a lot of organic matter left in the different heat exchangers and the different tanks. And the solar thermal system can collect hot water all throughout the day. And then at nighttime or in the evening, is collected hot water around 80 degrees Celsius can be used to spray down all the beer brewing surfaces to prepare for the brewing process the next day. If you want more information about this project, please go to the link below, but also check out Project Green Foods, which is a EU-based project focused on energy efficiency and low carbon heat integration into the food and beverage industry within Europe. Next slide. So the second brewery of example here is the Hofmu Brauerei or brewery. This one is located in southeastern Germany and in the Munich area. And this one was one of the first real large-scale solar thermal projects within Germany, almost over 10 years old now. And this collector, as you can see here, was extensively put onto the rooftop to serve a number of industrial processes within the beer brewing process, mainly again the preheating of water, but also the heating of the cleaning in place tanks for the evening cleaning processes. So the benefit of using CPC collectors, and so CPC stands for compound parabolic concentrator. These are often these are a slight concentrating device that have a mirror behind the vacuum tubes. And the benefit of these is it allows for a higher temperature up to 130 degrees Celsius, which allows for a higher level of thermal storage. And if a boiling or steam application is needed, this can serve that need. But also this higher temperature allows for longer term storage, because your storage can be a bit smaller to store the same amount of energy overnight. The important aspect of this, or the great aspect of this, is that the Hofmühl brewery has been awarded this solar beer award for being able to produce 100% solar beer in the summertime months when you have the most amount of solar energy available. And I believe this is the first company to be awarded this by the Technical University of Munich. And this brewery has really served that as a great case study for a large-scale solar thermal introduction or integration of energy into the industrial beer process. Next slide. And finally, this is the Götzer brewery. This is located in Austria. So this is quite an interesting project here. There's been some good research done in this green brewing concept, which is available online, and this is to really find ways to make the beer brewing process as sustainable as possible, and to use as few fossil fuels to generate the beer that we drink. So there are three unique aspects, or are the main heat sources for this beer brewing process. One is solar thermal, and as we see here, there are around 1,500 square meters, about one megawatt of thermal energy possible throughout these flat plate collectors. And this is again hooked up to a large industrial storage that we see in the background. But what makes this project even more unique is that it's integrated with a district heating process, or a district heating loop, which is close by, but also an on-site biogas project. And so what they do here is they use the waste grains, or the spent grains, and put it into an anaerobic digester to make biomethane that can be burned either in a CHP to generate both heat and electricity, or just in a traditional boiler to generate the heat for the various beer brewing processes. And altogether, this is quite a landmark type example, and I highly recommend you visit the website below. This is a ship-plants.info. This is a website that has a very large directory of solar thermal process heat integration projects throughout the world. So if you ever have any questions or want some information about what solar thermal projects are going on in my country or within a similar sector in which I'm working, then please go. This is a wealth of information, and is very, very helpful if you're interested in designing such a plant for yourself. And so that really lines it up for me. This is a brief introduction of how solar thermal energy can be introduced into the beer brewing process to really make green beer. I look forward to your questions, and I turn it back to Arabella for the next speakers.
Thank you very much, Steve. We are now moving on to the second presentation, which is going to be on solar thermal heat for mining processes and the electronics we use. And you can see the graphic that we designed just now on your screen. And for this section of the webinar, we will welcome José Miguel Cardamil from Chile. José Miguel is assistant professor at the Department for Mechanical Engineering at the University of Chile, and he works as a researcher at SERC, that's the Solar Energy Research Center in Chile. And José Miguel was also scientific chair of the ISES Solar World Congress 2019 in Santiago, which we just had the pleasure to have. So I am handing over now to José Miguel.
Thanks. Hi to everybody. As Arabella said, I'm coming from Chile. I work at institution, a institute that is composed of 7 institutions. So we are working in a very large community regarding solar energy here in Chile, and we had the opportunity to organize the ISES Solar World Congress in last November. So regarding my presentation, the idea is to explain a little bit the context situation in Chile. I need to explain that because the particular opportunities that the copper mining industry offers, it's really a reflection about the Chilean context. So regarding the Chilean situation, it's really similar to what is happening worldwide, where about 40% of the energy is consumed by the industry, and where much of that energy it's used as heat. But in Chile, particularly, most of the heat is consumed at a very low level of temperature, because particularly the copper mining industry is the larger energy consumer in Chile, and they consume a lot of heat for their processes. But the interesting thing is most of the heat consumed by the copper mining industry is about 40 or between 40 and 50 degrees Celsius. So the opportunities for solar in that processes are huge. Regarding the copper mining processes, I need to explain a little bit because it's not really common, not as beer processes, for instance. The production process for the copper, it depends about the ore being processed. Copper is present at the environment in the form of oxides or sulfurs. Then the process for producing or for refining that copper depends on if you're processing oxides and sulfurs, where the sulfurs requires low energy, or low heat for that process, except for the smelting process, which is highly energy consumer, but the process is about 1,000 degrees Celsius, so the opportunities for solar are not really evident. But regarding the oxide processing, that process is called hydrometallurgy, and heat in this process is used specifically for the electrowinning process, and also maybe for leaching. But that heat is used about, as I said, between 40-45 degrees Celsius until 50-55 degrees Celsius. So the opportunities here for solar are more than evident. And particularly in Chile, also, besides the copper mining facilities, we also have a lot of sun. Chile has one of the highest solar radiation availabilities worldwide, and particularly most of the copper mining facilities are located in the area where the highest radiation levels are observed. So we not only are producing copper, but we are producing copper in the places where most of where the sun is available at large. But that also have particular features. I have a line in the map up there, because if we take a look about the topographic profile of Chile, I took a screen from Google Earth. You can see that the topography in Chile goes from the sea until almost 5,000 meters above the sea level in a distance about 200 kilometers. So what want to show here is most of the copper mining facilities nowadays are using fossil fuels for heating their processes, but they are bringing the fossil fuels from the sea, from a port up to 200, 300, I'm sorry, 2,000 or 3,000 meters above the sea level where the facilities are located. So the opportunities are not only because about the savings that solar can give, but also about all the savings that we can observe about transportation, for instance. So what is in summary, copper mining facilities are located in high altitude, and most of them have high solar availability. In addition to that, we in Chile do not produce significant fossil resources, so the opportunities are quite great. So how is the process integration for solar in copper mining facilities? It's a very simple scheme where the solar field hits a storage tank, and using two heat exchangers, we can deliver heat to the electrowinning process. The electrowinning process is where the cathodes are produced itself. So the idea is to deliver the heat during almost 24/7. Most of the copper mining facilities operate in that regime. So the storage tank and how to operate the storage tank is quite an issue. Regarding the examples, in Chile we have two plants currently in operation. One located in Minera Centinela. They are using a small concentrating solar collector, parabolic trough, but it's a small parabolic trough. Actually, the absorber tube do not have any vacuum. They work using pressurized water as working fluid, and they have a 300 cubic meter of storage size. The solar fraction at the design point, it's about 55%, and the fuel savings expected are about 55% too. They had some issues during the operation during the last years, but they are reaching those levels of efficiency nowadays. In that picture, so you can also see how the desert is and how the sky is pretty clear, and also the location of the storage tank, which are 3 storage tank of 100 cubic meter each. And the largest installation that we have is located at Minera Gavi. It's the mining company, it's Minera Gavi, but the solar company, I mean, there's a different company that owns the solar collectors, which is Pampa Elvira Solar, and that company sells only the heat to the mining company, operating in a ESCO business mode. They are using flat plate collectors. The surface is almost 40,000 square meters, and also the solar fraction of this solar field is about 55%. But the fuel savings here are about 80%, and with a lot of CO2 emissions reduction. The operation of this plant is it's better, it's very stable, and they are planning new installations for the upcoming years. New opportunities are also present because the currently operating, the currently project, they are replacing heat from boilers, but new developments and new researchers have demonstrated, have proven that the use of heat in leaching and also the solution heating can increase the copper productivity. And that is part of the new projects that are in development nowadays. But not everything is good. We have several issues regarding the water use. We are in the middle of this desert, so the water availability is quite an issue, and keeping the collectors clean is a significant challenge nowadays. So that is more or less what I wanted to say. It's a quick description about how the copper mining processes are and the huge opportunity that offers for solar. And we and my team, we have a recently published paper, so where most of the details you can find on that, it's in solar energy. So that's it. Thanks.
Thank you very much, José Miguel. Coming back to our infographics just in a second. So thank you for that second presentation on mining processes in Chile. And now we are heading over to the third and final presentation, which is going to focus on solar thermal steam, which is a bit different to the things we've heard so far in the production used for pharmaceuticals. And you can see the infographic we designed along on the screen right now. And then I'd like to introduce our next speaker for this topic. This is Martin Hagen. Martin Hagen joined Industrial Solar in 2012, and he's there responsible for the business development in the MENA region. And he has been leading the development of 2 projects for Industrial Solar in Jordan. And he has additionally been involved in the consultancy projects focused on policy for solar process heating. And Martin is now going to introduce us to an application for solar steam. Martin, I'm handing over to you. There we go.
Thank you, Arabella. I'll just share the screen. I hope you see it.
Yes.
Great. Okay, sorry. I don't want to go to it. There we are. Sorry for the start. Good morning and good afternoon from my side. As mentioned by Arabella, my name is Martin and I'm working for business development of Industrial Solar. For those who don't know Industrial Solar, we are a solution provider for solar process heating, and our solutions are mainly, but not exclusively, built upon the Canal Collector. It's a special solar thermal collector. You will see some more details on the collector later in the presentation. But we are also not the only manufacturer of Canal collectors worldwide, but our one is specifically designed for applications in the industrial sector. Today I will talk about projects in pharmaceutical projects for solar steam generation in Jordan. So it will be briefly upon Jordan, briefly upon the pharmaceutical sector, briefly on solar steam generation, and let's see how these things work out together very well. A brief background on Jordan and the pharma sector. Similar to what Jose just mentioned for Chile, Jordan is also blessed with very high irradiation, so very suitable preconditions for the application of solar thermal energy, and unfortunately or fortunately, very high fuel prices, so which for us as a solar thermal company makes it very promising to operate there. In addition, the country also has quite ambitious targets for renewables, and like in most other countries, these targets and progress on the electricity sector are a bit advanced compared to the thermal sector. And again, thermal sector, we have to talk about industrial process heating. So luckily in Jordan, there are also, similar to Chile, good examples of projects being in operation already. In addition, and now this is the link to the pharmaceutical sector, Jordan has considering the small country size, quite a strong pharmaceutical industry. It works kind of as a hub, providing not only in its inhabitants, but also doing quite a lot of export in the region. This is historically grown, that for decades already the pharmaceutical sector in Jordan is rather strong. So below you see some examples of processes, but basically, and that's already one of my key lessons, I don't want to go into the details of the processes for the pharmaceutical sector. More why I don't want to do this later, but bottom line, pharmaceutical sectors, pharmaceutical industries, regardless what they are doing, they have a quite high demand for thermal energy, so high compared to electricity, not as high in absolute terms as eventually the mining sector, but pharmaceutical industries need heat. And also we have to talk about temperature. So the heat is always below 200 degrees C, and depending on the process, it's below between 50 and 130, maybe 140, 150 degrees C. So all well in reach for concentrating solar thermal. And most pharmaceutical companies actually have a heat grid operated or run with steam. So a central steam supply provides all these different processes with the heat at the parameters of the individual process. I think this is basically covered already. So what you see here also holds for the pharmaceutical sector, that most of the pharmaceutical demand, energy demand, is actually heating. And this was also, and now we can directly transfer to the project in Jordan, the Pharma project. As you see here in the middle, the demand for steam generation was also for Pharma, our first client in Jordan, the major single energy cost. So Pharma is a comparatively small pharmaceutical company, nevertheless operating for almost 3 decades nationally and internationally. And already several years ago, long before we implemented the project, they looked into green technologies and thus identified that talking about emission reduction of their processes, they have to look into process heating. Process heating is, despite differences between the processes, especially steam generation, which is the major, or which is the single supply for all processes. In addition, what was good for us, that the company had suitable preconditions for the installation of Canal collectors. So here I'm talking especially about installation area. So they had a suitable roof, the collectors installed on a roof, which had the ability to cover the load, and in addition was also quite close to the boiler room where we feed in, and the load profile was also suitable. The project at this time, when it was installed in 2015 or commissioned in 2015, was realized in cooperation with the GIZ, which is the German Organization for Development Cooperation. Finally, now, here you see the project, the collector installation on top of the roof of the Pharma factory in Jordan. So these bars, for those partly like enlightened already on the roof, that's exactly our collector. I will go into the technology in a bit more detail later. What you see there are 18 modules of our Fresnel collectors. So you see 2 strings in which they are aligned. Maybe that's easier if I switch here now already to the next slide. 18 Fresnel collector modules, a total aperture area of almost 400 square meters. And in addition, a roof storage, also more details later, with a capacity of 2 cubic meter. And as I mentioned, it's installed on roof, which is important to reiterate because industry is often space constrained. So direct steam generation, again, already mentioned. And what we do here is we generate steam at up to 210 degrees C and providing steam to the client at around 160 degrees C. And that's well beyond the highest temperature of their processes, the individual processes, but they distribute as they have been doing it in the past. And the integration is parallel to the existing steam boiler. Also a bit more detail will follow on this part. Very brief on our collector. So there, this is what you've seen from the side and from below in the pictures before. So the Fresnel collector is a concentrating solar thermal collector with uniaxially tracked mirror rows. of 11 rows per module. They follow the sun, reflect the sunlight onto an absorber tube through which a heat transfer fluid is circulated and heated, and from where the heat is fed into the processes or supply grid. So for us specifically, we focus rather on high quality components, which allows us to reach rather higher temperatures, maybe a bit higher than some other companies, but that's not necessarily the only approach possible. And if you design for other temperatures, eventually the collector would look slightly different. But I don't want to go into the details now. Another part I would like to stress is that it's possible to install it on the roof due to the low weight and low wind load, and that's again important for industrial steam generation where space is mostly constrained. Here again, a picture to what I just mentioned. On the top left, on the bottom left, you see the roof storage, and behind you see the two strings of the collector modules. And here we come, as I mentioned, to the roof storage. For solar steam generation, I would like to mention this because the storage is more than just a storage. It has several further functions which are actually necessary to operate the collector in direct steam generation mode, what we do. So the water which circulates through our collector is the same like which goes to as steam to the factory later. So apart from just storing, what we need to do in what the storage does in addition is it separates steam from the condensate, allowing that we can charge or we can discharge dry saturated steam at the required parameters to the client. It serves as a pressure maintenance when the pressure changes within the collector and storage over the time due to changes in irradiation and changes in offtake. And in addition, it's a water reservoir, for example, when we flush the collector, when we empty the collector for whatever reasons required. So, and these functions actually are crucial for the operations. So why we could minimize the volume or increase the volume depending on the requirements in respect to load profile, we do need a storage for these installations, as a storage has further functions than just pure storage. So we need the functions. The storage serves additional functions, the ones I just mentioned, in addition to buffering the heat when there's more than is currently required. Here you see another view. I have to be honest, also us, this collector is also installed in a rather dry area, so also cleaning for us is for sure a challenge, and the collector most likely will not always as clear as it does here, but that's conventional part for, I think, for all solar thermal collectors and all other solar equipment. Same requirements would a conventional fuel boiler have for boiler operations. So also here we do have these effects requirements for maintenance. Now, and I think that gets a bit more interesting for most of the audience, is that we have a closer look in the PNID simplified. So here you see what I mentioned. In the central is the steam drum. The blue line takes cold water. Cold water means, for example, 130, 140 degrees Celsius from the steam drum, from the bottom of the steam drum. Pure water, it circulates through the collector field, whereas pure water enters the first collector and the mix of water and steam leaves the last collector. This two-phase flow will go to the steam drum again, where the phases are separated, and from the top the steam is disclosed via pressure control valve to the factory, and from there this it's fed to the individual processes. And at the same time, if there's insufficient steam supply from the solar collector, the conventional fuel boiler, which is always in operation, I have to say, at least as a backup, meets the insufficient or the missing supply, which cannot be covered by the solar collector at a given time. Similar to what was mentioned before, so during the summertime, we reach times where we could almost supply the complete factory with all the requirements. Accordingly, the boiler operates at minimum capacity, whereas in winter times or early morning and evening times, the conventional diesel-fired boiler has to cover most share of the load. And I mentioned also that the volume of the steam drum is 2 cubic meters, which would meet, if it's empty and then fully charged, roughly half an hour of peak production. But this is only one design, and it could look different for a similar or for a different collector. Here you see another picture of the installation on the rooftop, and again something summarizing what I've just mentioned. I would also like to look into the performance. That's what you see here below. Okay, no, it's not mentioned in the presentation I will share. You will get the source for this chart to study it in a bit more detail. The bottom line I want to stress: the yellow line is the irradiation, and you see it's fluctuating over the day. Clearly, there is a fluctuating demand within the process, which we cannot show here because we don't control it and we don't measure it. But accordingly, there are fluctuations on the supply side, namely the irradiation, and there are fluctuations in the demand side, which is the offtake of the individual processes. But nevertheless, the violet line is is the pressure, and as you see, and it's written there, so despite these fluctuations of demand and supply, the pressure in the steam grid is actually very stable, and is more stable than you see in the early morning when the pure fossil fuel boiler is operating the grid. So often I'm asked, how does it impact my reliability? I say it's not affecting negatively the reliability, quite the opposite. Actually, integrating solar steam generation stabilizes your steam supply in the factory. That's already my presentation. Maybe summing up and coming back to the title, the topic of this presentation was solar steam generation for the pharmaceutical sector. I have talked very little about the pharmaceutical sector, and that's also maybe one of the key messages. If we would have another webinar talking about the food industry, basically I could use the same, because for solar steam generation, we do not need to look into individual processes. Since the project was installed, none of the industrial solar employees ever entered the production area of the Pharma facility. So we stay on the utility side, we stay on the supply side, and this in addition gives also the great flexibility if, for example, one process is stopped for one reason or another, or if the processes change, the steam supply is still able to cope with the changes on the demand. And this is a very important factor for the industrial demand. Also, I would like to stress that since I stressed these positive parts, it's not the only technology we supply, and clearly you have to see what are the requirements of the individual off-taker, what are the constraints of the off-taker, to see whether or to which extent this technology makes sense for specific application. So you see here a bit also a link of a video with more information, also the off-takers speaking. Maybe their views are also interesting for you. And I thank you for your interest, and I'm looking forward for your questions. Thank you very much.
Thank you very much, Martin. We are now heading into the Q&A section. And for this, I'm handing over to Steve, who collects your questions.
All right, everybody. Thank you very much for your time so far today. We have some good questions for the audience. First, I'd like to go into, I guess, a bit of the financial side of things. Now, both Jose and Martin, you guys brought up that in these projects, you guys use sort of an ESCO business model, and I'm wondering if you can explain a bit more how this works, and like how customers will pay for the service, and also how do they deal with any sort of long time delays if it's not sunny for a day or a week or a month. How does that affect into your ESCO model with these projects?
This was addressed to me, Martin?
To both Martin and Jose. Both you guys discussed ESCO projects within your business. So Martin, you can go first.
Yeah. So ESCO, the business model is actually what is required by most industrial off-takers for non-technical reasons, purely as they don't want to invest in projects which are capital intensive and away from their core business. So the biggest constraint for the technology as such is not technology, but the business model or the financing. Solar processing contracting can overcome this, but in this case, basically the questions which we offer, or the questions which need to be addressed: what happens if there's no sun? In this case, the ESCO takes the risk, so the ESCO has to design and price the heat, deliver it to the client. When the sun is not shining, client is not paying. Mostly the price is fixed at a rate below the current fuel price. So from this perspective, there are little risks for the clients, quite beneficial. The challenge is rather to agree on a joint minimum offtake in order that the ESCO can be sure that all the heat, or most of the heat they provide, is actually taken or at least paid for by the client.
And Martin, just to follow up there, what happens if your solar steam system does produce steam, but the off-taker does not demand any steam at that time? Is there any sort of contractual purchase for those instances as well?
Yes, it's the most difficult part in designing such agreements. So we basically would require from the client certain minimum offtakes, which hold not only in the total megawatt or gigawatt hours produced per year, but also to know that, for example, they take heat at least on 340 days per year for at least the following hours and in total the following megawatts. So to some extent it can be priced in. No need to consume all. That's quite normal that the factory is off or the demand is low, but they have to make commitments that we are sure that most of the heat is taken and paid for.
All right, thank you. And Jose, would you like to share your experience down in Chile working within the ESCO model?
Yeah, actually, I'm working at the university, so it's not my company that is running the ESCO model. So Martin's opinion is way more close than mine. Nevertheless, I can tell you that ESCO model is consolidating in Chile, at least for the mining companies, because as Martin said, companies rather to use this business model because solar thermal is, especially for large solar thermal fields, you need that projects are really capital extensive in using capital expenditures. Sorry, so that's somehow it's more suitable for the operation in companies, and especially for companies that are much more specialized in particular production processes, and solar heat is not in the core business of them. And in addition to that, what you were asking about what happened if in a couple of days or even in a week we don't have enough sun, that really don't happen in the Atacama Desert. That is something good. However, as Marty said, there's a very you have to spend a lot of time when designing the contract, because you have to ensure that the client is going to take the heat away, so the solar plant can operate almost constant or in the best efficiency. And also in cases of when low solar radiation, or even in some particular meteorological events, so you still have a backup, a fossil backup to operate and to deliver that heat. In that cases, or even the ESCO client or the ESCO provider could pay the fossil fuel or the operation of the boiler. That depends on the contract that you sign.
Okay, great. Thank you, Jose. Moving on to another similar line of conversations is the cost of heat, because oftentimes this is a big sticking point when comparing solar thermal heat to that made with fossil fuels. In the regions like in Jordan and in Chile, the sun is quite abundant. So what sort of, if we take about a 20-year time span, what is your typical levelized cost of heat that these solar thermal systems can deliver? And are they currently competitive with the fossil fuel competition, let's say, in your respective countries? Martin, you can go first for the Jordan example.
So for Jordan example, definitely they are competitive to all fuels which are available in the market, the cheapest one being heavy fuel oil. The cost of heat then depends a lot on the size of the installation, whereas bigger installations are substantially cheaper due to large economies of scale. But as an average, the price per megawatt hour would be in the range of 35 euros to 45 euros per megawatt hour for a 20 years period.
Right, thank you. And just real quick, that's about 5 cents per kilowatt hour US, about 4 cents US. And Jose, what is your opinion on this?
Yeah, in Chile has a bit higher solar radiation, so the LCOH, the levelized cost, could be reduced a little bit, maybe 30 euros per megawatt hour, but it, as Martin said, that depends a lot on the size of the solar field, on the size of the storage tank, on the storage system, and also about the temperature of the process. So it's more, I cannot take just a value, it's more like a range. There are some projects that are offering levelized cost even lower than 30 euros, maybe 20, almost 28, 27 euros per megawatt hour, but on other projects about up to 40 euros per megawatt hour. So it depends a lot about the design, depends a lot about the applications, but that's more or less the range.
Can I add something, please?
Sure.
So in addition, fully agree to what Jose just mentioned. In addition, the financial aspects or economic aspects matter a lot. So a very big impact has the financial due diligence and creditworthiness of the client, which can kill the complete project or make it viable, or in parallel to this, whether there are suitable, for example, guarantee schemes by any public entity. So I would say that these non-technical parts are as important, have as a big impact on the final costs per levelized cost of heat as the technical parameters just mentioned.
Okay, great. Thank you, Martin. And the last question, which I'll answer myself, is how does a solar thermal system deal with the seasonality of production? For example, in mining and pharmaceutical, there may be a constant demand every day throughout the year, but for more agricultural type processes like food and beverage, there is a seasonal aspect. For a prime example, beer in Germany, there's more beer brewed for the summertime crowd than for winter, just based on habits. So in this case, this is quite an advantage, because the summertime is when there is more solar thermal energy to be collected. But if there are agricultural drying things like after harvest season in September and October, and no other energy used throughout the year, then solar thermal may be a more challenging application. The best integration of solar thermal is a process that has a near constant demand throughout the whole year. And if it does vary, that it does have a higher demand in summertime than in winter. That there is opportunity for long-term solar thermal storage, but this is mainly done in the very large scale in the solar district heating realm, which is quite popular in Denmark and in Germany. And to wrap up, just that there are a few other questions about who is the target audience for the infographics. And first, the target audience is everybody who has interest in learning more about how renewable energy and solar thermal energy can be one solution in the industrial sector to really reduce climate change, or to reduce carbon, to reduce the risk of climate change. But it's for anybody from students to professors to people who are within governments, to help provide more information to make better decisions about our energy future. The final question before we wrap things up is, how can people participate? So ISES is always available to, if you have ideas, if you want to help take action, however you want to support the integration of solar thermal into industrial processes. If you have good examples of projects that may be going on in your community, please reach out to Arabella and the International Solar Energy Society. They will be happy to help link you to some experts to continue the conversation and to best support the growing revolution of solar thermal energy, especially for the in process heat. And with that, I think we're a few minutes away from 10 o'clock. Are there any last comments from Jose or Martin? And if not, I'll turn it over to Arabella to wrap things up.
No comments from my side, apart from saying thank you also to ISES to work on these topics.
Same from my side. No comments, just acknowledge the effort and also thank the opportunity and the invitation.
All right, thank you everybody, and thank you to our speakers for joining us. I think we had a very fruitful discussion, and we received many questions, and sometimes time just doesn't allow for all of them to be answered, but we will certainly make sure to forward them to our speakers afterwards. And then now, before we end the webinar for today, I'd like to take the chance one last time and give you a few more information. First off, this webinar is being recorded, and you will find the recording as well as the presentations online on the ISES homepage within the next 1 to 2 days after this webinar. And you will also receive a follow-up email, which is going to highlight to you where you can find it. And then to our ISES members, I want to remind you that you already have the unlimited access to all past ISES webinars and presentation. This is a special ISES members benefit, so remember to log into your ISES member area, and then you can have them all there ready for you whenever you want to rewatch them. And then now, before we end, we already have the next webinar lined up, and I want to invite everybody to join us for that as well. This is going to be on March 25th, again at 2 p.m. GMT, and this is welcoming back again the IEA HSC Solar Academy, and they are going to present work on their task 60, which is PVT systems, and the title for the webinar will be Solar Heat and Electricity PVT Solutions for Buildings and Industry. So once again, this is going to be on March the 25th. Registration for this is already open. You will receive invitation emails for this soon as well, and you can already find more information on the ISES homepage. And then one more event that's coming up for us somewhat soon already, even though the year just started, is the next big ISES conference, which is going to be Eurosun 2020. That is the 13th International Conference on Solar Energy for Buildings and Industry. And for this conference, we have the call for abstracts as well as a very special call for keynote speakers open. Both deadlines for both of these calls is the 31st of March. You can learn more on our homepage, which is eurosun2020.org, and we are looking forward to welcoming many of you in Chile. Not in Chile. Chile we just went to. Sorry, in Greece. Next time it's going to be Greece. Okay, and now for my final announcement. Obviously, I just said there's going to be recording, and you will receive all the necessary information for that in an email. As always, please reach out to us if you have any feedback, any comments on this webinar. You can see our email just there. It's public.relations@ises.org, and you can email us if you have any questions about upcoming events or the stuff that ISES does. And there's also going to be a survey attached to the email you will receive, and this survey really helps us prepare the best webinars we can for you, so your feedback is highly welcomed. And yeah, we are looking forward to it. So with this, I'm going to close the webinar. I wish a good day to all of you, wherever you are in the world. We will now end the webinar and see you soon next time. Goodbye.